All right, guys. Sorry, I had a little bit of a hiccup here. I'm trying to make a video here. All right, so lesson 3. We're talking about graphs of exponential functions. See, graphs of exponential functions. All right, so the classwork is, we got an example. Consider the story. Daryl lives on the 3rd floor of his apartment building. His bike is locked up outside on the ground floor. At 3 o'clock p.m., he leaves to go run errands, but as he is walking down the stairs, he realizes he forgot his wallet. He goes back up the stairs to get it and leaves again. As he tries to unlock his bike, he realizes that he forgot his keys. One last time, he goes back up the stairs to get his keys. He then unlocks his bike and is on his way by 3:10 p.m. Sketch a graph that depicts Daryl's change in elevation over time. Okay, so here's the thing, okay? All right, so let's go through this. First off, okay, at 3 o'clock, okay, Daryl is leaving the 3rd floor. All right, he's leaving the 3rd floor of his apartment building. All right, at 3 o'clock, he leaves to go run his errands, but as he's walking down the stairs, he realizes he forgot his wallet. He does not make it all the way down the stairs. Okay, so at some point, he goes back up to fetch his wallet. Okay, then he comes back down. He goes back up the stairs to get it and leaves again. So again, at some point, he's at the 3rd floor. All right, and then he makes it all the way down to the ground floor to his bike. Okay. But then as he tries to unlock his bikes, he realizes he forgot his keys. So he has to go back up again. So he goes now, he's gone. Okay, so here we got 3rd floor of the wallet. Then he's got to go from whatever floor he's on back to the 3rd floor. Then he's on the 3rd floor and he's all the way at the ground floor. The next time, he's got to go from the ground floor back to the 3rd floor. Okay. And that's because he forgot his keys. So he has to go back up to fetch his keys. Okay, so here's the keys. This is where he's going to get his wallet. Okay. And one last time, he goes back up the stairs to get his keys, and then he unlocks his bike, and he's on his way at 3:10. So at 3:10, okay, he goes from the 3rd floor to the ground floor. So now we have all the information we need in order to sit here and really graph this. Okay, so here we go. Nice little, oops, let me come up a little bit so you can see what I'm doing here. All right, got a y-axis. We got our x-axis now. Okay, change in elevation over time. Okay, this is going to be our time down here at the bottom. Okay, we're going to say this is 0 minutes here. It's the origin. So 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes pass, 6, 7, 8, 9, 10 minutes passed. Okay, and then this over here is going to be our elevation. Okay, we're going to say this is the ground floor, this is the 1st, this is the 2nd, and this is the 3rd. So he starts at the ground floor. Okay, then he's, let's see, we got 1. So this one here, let's say it took 2 minutes. Okay, so he goes down, then comes back up, takes him 2 minutes. To go from the 3rd to the ground floor, we're going to say it takes him another, 3 minutes. Okay, and then takes him another 3 minutes to go back up. And then last but not least, takes him, I'd say take him a minute here, okay? Since he didn't go all the way down, and then it takes him 3 minutes before he has to leave. Okay? So to go from the 3rd floor to where he gets his wallet, we'll say he makes it all the way down to the 2nd floor. Okay? That's where he forgot his wallet, okay? Now he's got to go back up to the 3rd floor. Okay? Then he's got to go from the 3rd floor to the ground floor. All right, 3rd floor to the ground floor. Oof. Give myself a little bit of a eraser here. Okay, so I'm trying to go to here. Okay, so from the 3rd floor to the ground floor. When he gets to the ground floor, he realizes that he's forgotten something. So he has to go all the way back up to the ground floor, all the way up to the top floor again. So we're going to go right about here. So you got to go all the way back up here. Then he's able to come all the way back down, and he's out of here. Okay? That's our 5 points. 1, 2, 3, 4, 5. 1, 2, 3, 4, well, 5 and 6. All right, still. But we started here, so 1, 2, 3, 4, 5. So 5 points. Okay. So that's pretty much his elevation and change over time. It's kind of a little weird and funky, but this is just based on the assumption that, he followed a certain timeline, but we don't know the timeline, so we're having to estimate, okay? So that's basically what it would look like. Up, down, up, down, up, down, up, down. All right? Now, supposed to have a video for you to watch, so let's see if I can get the video to come up. All right? So bear with me. See, I'm even on my own page here to sit here and try to take care of somebody else. So, hi. All right, so let's see. We're supposed to go to www.youtube.com/watch $V equals GEWZ DY DCI WC. Let's see if that's right. All right, just got to wait.
Oh, Mr. Hale, why do I have to wait on this video? Video. Video. Video, 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 video. Video.
Video. Video. Aww, video unavailable. That made me sad. No video means no video. That's just not fun. Alright, well, we're gonna have to minimize. Sorry guys, no video. We'll have to try something else later on. Okay. Alright guys, something happened. I don't know what happened. For some reason my screen closed on me. Okay, so technically what we're supposed to have done is graph the number of bacteria versus time in seconds. So begin by counting the number of bacteria present at each second and plotting the appropriate points on the set of axes below. Consider how you might handle estimating these counts as the population of bacteria grows. Alright, so the video was supposed to show bacteria doubling every second. Alright, so at 0 seconds, okay, obviously we don't have any bacteria. Okay, but let's say at 1 second, we got, let's see, let's go 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Okay, so at 1 second we had 2, and then it doubles. So if we had 2, then that means we had 4 at 2 seconds. At 3 seconds, now we've got 8 because it doubles again. 4 times 2 is 8. 8 times 2 is 16. So after 4 seconds, we got 16 bacteria. After 5 seconds, we'd have 32. I ain't got a space for 32. So what you do is you graph what you have. Okay? And this is what you call an exponential function. Okay? In other words, okay, time in seconds versus bacteria. Okay? So your exponential function would be y equals x squared. Think about it. If y was at 5 seconds, well, it's not really fair. It's not really the way it's supposed to look. Never mind. My bad. Ignore me. Ignore what I just said. Okay. All right. So graph the number of bacteria versus time in minutes. Oh, that's no fun. Okay. Let's go. Oh, wow. That's a lot of bacteria, guys. You know what? Hold on a second. See, the thing is that even if we couldn't see, so like right now, I can't tell you exactly how many bacteria there were in a certain number of minutes because I don't have the video. However, what we can do is we can make an assumption. As you can see from the first graph, this starts to curve very quickly up, okay? So the same thing should happen in a time minutes. So you could sit there and say it would look something like this, okay? It curves up. It's not a straight line, it curves. So in an exponential function, you're looking at a possible curve, okay? Um, Oddly enough, that actually looks pretty darn close to what I was looking for. All right, and the same thing would go over here and graph the number of bacteria versus time in hours, so in 1 hour it'd be here, in 2 it'd be here, in 3 it'd be here, and so forth, okay? You're looking at an exponential function, so it would start to curve very quickly. It would become steep very fast, okay? So exponential functions start off looking like they're low, but then they start getting higher and higher and higher as you're moving along. These are known as exponential functions because they increase exponentially. Okay, that's basically what an exponential function should look like. I'm not really pleased with what I'm seeing here, guys. Uh, so this is what I want you to do tonight. I know it's a short video. Um, I don't want you to do anything with the problem set tonight, okay? I actually want you to go to Khan Academy and I want you to watch videos on exponential functions. Specifically, if you can find them, how they graph, how you graph an exponential function, that kind of stuff. That would be much more preference. Okay. Um, what I will do is I will see if I can't find something because this is very short lesson. I'm not really pleased with this. So I might let you watch this video, but I might actually have something else for us to do in class tomorrow to add to it because we need more than just this when it comes to exponential functions, guys. I'm sorry. So just be patient with me. We'll get this squared away and we'll get some good learning going in, okay? All right, guys, you have a good night, and I will see you all bright and early tomorrow morning.